This is 2025 AMC 12B, problem 23. Let S be the set of all integers z greater than 1, such that for all pairs of non-negative integers x, y, with x less than y less than z, the remainder when 2025 x is divided by z is less than the remainder when 2025 y is divided by z. What is the sum of the elements of S? So the key thing with problems like these is to try to look at the bigger picture. So instead of looking at pairs of numbers x, y, we can think about the set of all the different numbers x less than z. So I'll show some examples for small values of z first. So let's just try to problem for small values of z to get a feeling for what exactly is going on here. So first, let's try the smallest possible value of z equals 2. So we have, the only pair x, y that we can pick is 0, 1. And we can check indeed 2025 times 0 divided by 2. That's going to give us a remainder of 0. And 2025 times 1, that's 2025. So when we divide it by 2, we're going to get a remainder of 1. And indeed, 0 is less than 1. So z equals 2 is a valid solution. It is in the set S. Okay, then we can try z equals 3. So we could try all the different pairs of numbers 0, 1, 0, 2, 1, 2, and compare all of them one at a time. Or what you could do faster to check all of the different pairs at once is we could just calculate all of them, right? And then look at all of them at once. So we can just calculate 2025 times 0, 2025 times 1, 2025 times 2. And if we take them mod 3, well, 2025 is a multiple of 3, so we're just going to get all zeros. So as you can see, obviously, if we take any sort of pair of numbers, we could pick like x is 0, y is 1, just for example, and the remainder of both of these is going to be the same. So the first remainder is not less than the second remainder. So 3 is not in S. So 3 fails. Okay, let's try one more number, right? Z equals 4. Well, we can check 2025 times 0 is going to be, so I'm going to use the equivalence notation, right? It's equivalent to 0 mod 4. 2025 times 1 is equivalent to 1 mod 4. 2025 times 2, we can check, that's going to be equivalent to 2 mod 4. And 2025 times 3 is going to be equivalent to 3 mod 4. And of course, we don't even need to check all of the different pairs of numbers x, y here. You can see visually that no matter what pair x, y we pick, it's definitely going to work, right? So for example, if we picked x equals 1 and y equals 3, the two remainders we would get are 1 and 3, and indeed 1 is less than 3. So as you can see, because we have an ascending list here, an increasing list of the remainders, we know that every single pair of numbers that we can pick is going to give us the first remainder less than the second remainder. So hopefully now you see that instead of thinking about just each different pair of numbers x, y, we should instead think about accumulating or like ascending through all the different numbers x less than z and writing down all the remainders one at a time and thinking about like what they are mod z. So essentially what we want is so we think about 2025 times 0 mod z, 2025 times 1 mod z, and we just write down this list, right? So as we went for all the numbers x less than z, so we go all the way up to 2025, we go all the way up to z minus 1 mod z. And as we just saw, the only way that we can have that if we pick any pair of different remainders in the sequence, we always have that the left one is less than the right one. The only way that that's always going to happen is if this sequence is strictly increasing. And this is pretty easy to prove, right? If you just have like a bunch of numbers and you have that no matter what pair of numbers you pick, that the left one is going to be less than the right one, you can just pick the adjacent pairs of numbers, right? So you have that A has to be less than B has to be less than C has to be less than D has to be less than E. So in this case, in general, if we just pick all of the different pairs of numbers, so we pick x, y as like 0, 1, 1, 2, etc., up to z minus 2, z minus 1, then we get that all of these different remainders here will have to be in increasing order. Okay, well, that's pretty interesting. But can we go further than this? Can we figure out something even more specific about what these values have to be? Well, remember, there are z of these values, right? One for each number from 0 up to z minus 1. So there are z of these remainders written down. And they're all numbers taken mod z. And when you divide something by z and take the remainder, well, a remainder has to be a number from 0 up to the number we're dividing by, minus 1. So all of these numbers here, since they're remainders of dividing by z, they all have to be integers between 0 and z minus 1 inclusive, and they have to form an increasing sequence. So hopefully you can tell now, since we only have z values to work with and they all have to be different from each other, each number has to be a number from 0 to z minus 1. And therefore, since the numbers have to be sorted, we have to start with 0 and then work our way up all the way up to z minus 1. So essentially, we get that 2025k has to be equivalent to k mod z for all k. And this is really important because it tells us some essential information about what z has to be. So if we subtract k from each side, we get 2024k has to be equivalent to 0 mod z for all k. So since k equals 1 is definitely a valid value we can pick, we can always pick k equals 1, then that tells us 2024 is equivalent to 0 mod z, which tells us that z has to be a divisor of 2024. And in fact, this condition is not only necessary for z to be an S, but it's also sufficient, because if z divides 2024, then that implies that 2025k is equivalent to k mod z, which would imply that each of these values of the remainders are going to be 0 through z minus 1, which would indeed make it always work. So all of the divisors of 2024 work here. Okay, but we also have to remember that z equals 1, even though that is a divisor of 2024, that one isn't allowed. So it's all the divisors of 2024, all the positive divisors except for 1. So we have to find the sum of those. We can use the sum of divisors formula to find that. So we write out 2024 is equal to 2 cubed times 11 times 23. We can just factorize this pretty easily. You just divide out 2's until you get 253, and then 11 divides this number. Okay. And then to do sum of divisors, you just calculate sum of 1 plus 2 plus 4 plus 8, that's 15. Sum of 1 and 11 is 12. Sum of 1 and 23, that's 24. And finally, remember to subtract 1 because a z equals 1 is not allowed. And if we multiply this all out, we get 180 times 24 minus 1. Do one more multiplication here. We would get 400 and 4,320 minus 1. That's going to give us 4,319 as our answer. Yeah. After you qualify for the AIME, make sure to check out our latest AIME preparation book of 5 practice tests to continue your Math Olympiad journey. And make sure to explore our full collection of AMC preparation books on Amazon, MathTopia Press, which include practice tests and detailed solutions.